So guys, ready with today's session? Have you everybody of you revised through the previous class notes and session?
Yes, Kesri.
Okay. Any doubts there? Anybody? Okay. And did anybody attempt the sheet that was shared yesterday?
Yes, Kesri. Until what the topics we have discovered, we have discussed. I did, but few problems were not solvable.
The theory of everything that is required has been discussed, basically. Like if you are asking on that front that some theory extra needs to be discussed, that is not the case. Like whatever is required to solve the sums from that sheet has been discussed. The thing is, it's numbers and it's not an easy topic because sometimes you need extra things. So it might take some time, like for some questions, it might take 10-15 minutes initially to get tracked through. That's why I was telling, since there's a lot of theory, what you do is revise regularly through the class notes and the class sessions, then you will get acquainted. It will happen initially, don't worry. Gradually, you'll get the hang of it.
Yeah.
Okay. Okay, then class, moving forward, we'll have a very important concept today, and that would be remainders. And
Casey,
yeah, go ahead.
one thing actually in yesterday's sheet, what actually you're saying homework sheet, 2 to 3 problems are incomplete questions.
Okay.
Yeah.
Achha, which question numbers?
May I ping in the WhatsApp?
Yeah, sure, sure.
Okay.
Okay. So we will have remainders, and for remainders, there's a very important concept that is last digit. So just to clarify, guys, what are the values of this?
2, 4, 8, 16, 32, 72,
72. No, there's no
sorry,
72.
72, 64, 128, 256,
Yes.
512, 1024.
Yes, perfect. This is 1024. So we will have 2, 4. So can you guys look at the pattern of the last digit?
Yes.
Yes. And what is that pattern?
It is repeating 2486, 2486.
Yes. And that's where we arrive at the concept of cyclicity. 2486, and then this cycles repeat. 2486, again it will start 2486. Basically you will see this for almost every number. At max they have a cyclicity of 4, where a few numbers have cyclicity less than 4. For example, anybody can tell me any number which can have a cyclicity less than 4?
7.
7 will have a cyclicity less than 4?
Yes.
9.
9. 3. Okay.
4.
So 3 raised to 1 is 3. 3 ka square is 9. 3 ka cube is 27. 3 raised to 4 is 81.
81.
3 raised to 5 is 243.
23.
I can see 3971. The cyclicity of 4 will again repeat. 3971. So 3 is not the answer.
9 and 4.
9 and 4. 4
7.
raised to 1 is 4. 4 square is 16. 4 cube is 64. Perfect. And so on. Yes, again it will have 6. Great. 7 will be 7 raised to 7. 7 square is 49. 7 cube, it will again have last digit 3.
343.
Yeah. 7 raised to 4 is again 1. No, the
1.
cycle is 4.
4.
So we'll have some numbers. There will be some numbers which don't have it. So if I have to find, let us say the last digit.
11 has it. Only
Yeah.
one.
Yes. 11, because it only ends with 1. So when you multiply 1 with 1, it will only have 1. Perfect.
Same is the
So
case with 5 and 6.
yes, 5 will also have it and 6 will also have it. Yes. You won't have to learn which has a cycle of 4 or which has a cycle of less. You can clearly see it in the exam also. The point is, let's say I'm given you 127 raised to 25. Now I want the last digit of this number. And guys, DM me in the chat box privately. The last digit. I've received 2 responses till now. Now it's 3. Let's see. I won't tell you if it is right or wrong. Let's wait. Let's wait 30 more seconds so that everybody answers, and then. Yes, guys, the answers you have given me are quite correct. Anybody who would like to share their approach? Yes, anyone?
What I did was Kesari. 7 will be multiplied uh, 5 times. So which gives the last digit 7, and this goes on 5 times again. So the last digit might be 7.
Okay, perfect. Yeah. Anybody else? Or did everyone use the same approach?
Pretty same thing, but I followed the 4 wala pattern. Like I saw 24 is divided by 4, so the rest will, the next series till done till the end, it will be only 1. The next one will be divided by 7, so I'll get 7.
Perfect. Yes, that's a kind of the plan. That's how you have to proceed. It's right. So since the main idea of knowing the cyclicity is any number that till divisible by 4 will have the same cyclicity, and then the cyclicity will start repeating. So 1, 2, 3, 4, and so on, every array till 24 will have similar cycle, and from 25 it will start having the same digit here, and that's how we get the last digit. But what about this, guys? Why don't we consider 120 as well? Why just 7? Anybody? Why
Because
have
it
we
is
considered just 7 and not 120 other digits?
Because last digit might be affected by units digit, I think.
Okay. Yeah, Aswik, you were telling something?
so it's asking for the last digit, and the last digit is only decided by the digit 7. Nothing
Why
else
so?
decided, because 7 is divided multiplied by 7, And the next in now 49, the next 7 will be again 9 will be divided by 7 first.
Okay, but then we don't have to consider this 1 and 2. Is that
No.
what you're telling them?
Yes.
Okay. What if I had to find the last 2 digits? Then
Then
do
you
I
have
had to
to
consider 12? I mean these 2 digits?
no, you have to consider 27.
Only 27?
Yes, I guess.
Okay. All right. Let's see then. All right. We'll move forward with that. Don't worry. You will have some questions wherein you will have to find pretty much what are the last 2 digits, and we'll see how those follow. So moving on, now let's move forward to the, so this is how the pattern method works, guys. In every, you will have sums wherein you will have to find the remainder. Let's say you will have to find the, like in this example, if I had to find the remainder when divided by 2, what will you be your answer, guys?
1.
Exactly 1, because the last digit is 7, which is an odd number. That means your remainder will be 1. So you'll have similar questions, and therein your pattern would be quite beneficial for you. Next, we'll be moving to the new concept, and that would be remainder theorem. Anybody who has studied remainder theorem before? You must have studied this in your 10th standard in your polynomials chapter. Anybody remembers it? Don't worry, I'm going to teach it, but still, I just want to see if anybody remembers it or not. Okay, nobody then. Fine. Let's discuss it. Okay, just moving forward, does anybody know what is a polynomial?
Square of 2 more than 2.
So 9 is a polynomial. It's more than square of 2.
Degree of the equation is,
Degree basically.
I think,
Degree what?
degree of the equation is, I think, 2 or greater than 2 or something. I don't remember exactly.
Okay. Okay. So give me an example of a polynomial.
Is it 2x square plus 3x plus 9 is equal to 0?
2x squared plus 3x plus 9 is equal to 0. Okay. Yeah, this is a polynomial. Okay. So basic notation for a polynomial is f of x. So f of x is a polynomial in x, where x is the variable used. And yeah, this is a polynomial. So polynomial is a collection of the terms in terms of variables and constants having a certain degree. And the highest degree is known as the degree of the polynomial. Perfect. Moving forward, if f of x is the given polynomial and I have to divide this by x minus a, my remainder will always be f of a. That means if I divide this by x minus 1, this polynomial, what my remainder will be is f of 1. That means instead of x, if I put 1, whatever value I get here, that will be my remainder. Try it, guys. Divide this by x minus 1. See what is your remainder, and then do this as well. Let's see what you get. Does the answer match? Let's test it.
The remainder is f of 1, right?
Yes, remainder is f of 1. This will be your remainder.
14 and 14.
Everybody got this part?
Yes.
Yes.
Okay, great. So now I guess the remainder theorem should be clear. Any doubts, guys? In understanding remainder theorem, if anybody has a doubt, I'll explain it once again. Okay, great, great then, no doubts. We'll move forward. Let's see an example then. So let's take an example. Now, what if 2 raised to 99 is to be divided by 9? What do I do? Now let's see. This is a polynomial. It's just that it's x raised to 99 and x here is 2. So what I will do is I will keep it as it is and change this to. Can I do this, guys?
Yes.
Okay. Now by remainder theorem, this is the polynomial. This is x minus a. So what will be the remainder, guys? What will be the remainder? If this is x, this is a, and this is the polynomial in x. What will be the remainder, guys?
-1.
How did you get it?
Hmm, yeah. I put x equal to a, and a we have -1. So -1 the power 33 times give -1.
Perfect. Yes. Yes, you are correct. We'll use the remainder would be f of a. A here is -1. So put -1 raised to 33, which will, since it is an odd power, it will give the answer as -1. Take one more example and let's see this time. So this time we have 2 raised to 70 divided by 7. Now solve it, guys. Let's see. This is slightly trickier than the previous one, but manageable. Take one more minute, guys. Interestingly, two different answers till now. None of them are correct. Manidip, you are close enough. I think you just missed the last important aspect. Asvik, no, your answer is not correct. Okay, let's try this out. So this is 2 raised to 70 and bottom is 7. So how can we relate 7 in terms of 2? 2 cube is 8 minus 1. So we'll have to represent the above thing in power of 3 as well, but it leaves a remainder of 1 when we divide 70 by 3. So what we'll do is we'll leave out 1 2 and then it will be 2 raised to 69, which can be done clearly as is this possible, guys?
Yes.
Yes.
Okay. Now I will take this x minus a. Now, according to remainder theorem, what is the remainder? F of a? A is
Yes.
1. So what is f of a, guys?
2 into
2
Exactly.
2.
2 into 1.
minus
Yes.
the 2.
Yeah, that's why I was telling you did a slight error at the last step.
Yes.
Is it clear, guys, now? How to apply
Yes,
f
yes.
of 1? Anybody, any doubt? Ask me right now itself. Okay, I see no doubts then. Let's move forward with one more pattern, and this time we won't use remainder theorem. We'll use a standard first theorem that we learned, that is the pattern making. So now let me ask you the question where you'll have to find the remainder when 2 raised to 97 is divided by 15. You can use your remainder theorem as well, but I would like to you guys to try the pattern theorem as well. You can verify your answers using both theorems, no issues. But answers privately, guys. 2 minutes. I have received answers from 3 people. 2 are correct, 1 is wrong. Aswek, your answer is wrong. Check it again. Anshula Manadeep, correct answers. Great. 30 more seconds, guys. I need answers from everyone. Yes, Pandana, right answer. Okay, let's discuss it then. Which method did you follow, guys?
I use remainder theorem.
Okay. And the pattern making theorem?
Pattern making also I have used Kesari after
Okay.
getting the answer.
Perfect. Others, did you use the pattern method as well?
Yeah, using pattern method only, I said something, but it was wrong.
All right.
Kesari, for pattern method, I did not get how to proceed. Like, say it is 97, right? So until 96, it is going to be the usual one, and for 97, it will end with.
Let's see how we'll solve. So we'll using both the methods then. Let's see first by pattern and then we'll see a trusted method of remainder theorem. So when let's take this number as x. So when x is 1, what is the remainder when divided by 15? 1. When x is 2, the remainder would be 4. Sorry, when x is 1, remainder would be 2, my bad. When x is 3, I mean power is 3, what will be the remainder? 8.
8,
When it's 4, 1.
16, 1.
Yeah.
No,
When it's
16.
5, yeah, 16 divided by 15, remainder would be 1, right?
Okay, fine.
Yeah. Now, when the power is 5, what would be the remainder? 2 raised to 32. Sorry, 32. 2 raised to 5 is 32. 32 divided by 15, remainder is
2.
2.
Even
6.
4.
64 divided by 15, remainder is?
4.
4.
Can you see a pattern building? 2481.
Yes.
This is the pattern of the remainders. So again, cyclicity kicks in. Now, when divided by 4, what will be the remainder here? 1.
Yes.
Then we will have to go to the first number because it will be 1, 2, 3, 4, 5, 6, 7, 8, so on till 96 should be here, and we'll get 97th here, following this pattern again and again. So 97th number will again repeat the remainder 2. That's how we'll get the answer. Everybody clear with this part?
Yes, please.
Anybody, any doubt? How
So
the
the answer is 4, right?
No, the answer is 2.
3, 4.
The last digit is 2, right?
Yeah, so
Remainder.
till 94 it is fine. So 95, 96, 97, 90.
Till 94, no, 96.
Okay, so
We
until
will get
96.
96 here.
Okay.
And I guess remainder theorem should be clear with everybody. Let's see remainder theorem as well. 2 raised to 97 and below we have 15. This is 2 raised to 4 minus 1. And now putting this as 4 as well, what do we have is because we had 97 here. Now what is my a, guys?
1.
1. So we'll put f of a, f of 1. That is 1 raised to 4 is 1. So the numerator will return 2, and that is my answer. Everybody clear with this part? Any doubts, guys?
No.
All right, great then. Uh, let's solve this one. Find the remainder when 3 raised to 101 is divided by 10. You can use whichever method you like. And I will give you 30 seconds. Now you should be good equipped to solve these questions. Quick, 30 seconds. Yes, Aswik, great. Great, Anshula. Yeah, Mandeep, right answer. Others? I've received just 3 answers. And your time's up. Yeah, guys, what happened to others? Spandana, Sohail, Prerit, I haven't received your answers yet. Are you guys stuck or are you not able to solve it? Yes, Sohail, right answer. Okay then.
So I have
Well,
small doubt.
yeah.
Can you explain me the last part of the remaining theorem because I'm not able to get it correctly.
Okay. So for remainder theorem, you want me to explain the theory or do you want me
Last
to?
part after getting with a x minus a, how to get the remainder last part.
Okay. Let me explain using solving this sum. So what will be how to get 10 to as close to power of 3? Can we do it 3 square minus 1? Now we have 3 square here. We need to express the numerator in terms of 3 square as well. So that would be 3 into 3 square is to 50. This part clear, guys? Now what we had in our remainder theorem, if we have a polynomial f of x and we divide it by x minus a, what will be our remainder would be f of a. That is, putting this a here, what is the value that is left? That will be our remainder. Now did you understand, Sohail?
Yes.
Okay. So what is our value of a in this question?
-1.
Sorry?
-1.
Yeah, -1. So when you put -1, what will you get?
Yeah, here is where I got stuck. Where should I keep the minus? Means see, then remainder will be 1.
We have to put this -1 in this part, right? Instead of this
Okay.
x, we'll put -1 here because this is our polynomial.
Okay. Yeah, I got it.
Okay, great. Now guys, let's move forward to last 2 digits problem. Till now we were only stuck with the last digit, the single digit. Now we'll move towards from 1 digit to 2 digits. Here you will face questions like if the same 301 is divided by 100, what will be your remainder? Or similar questions, you will be asked what are the last 2 digits. And well, pattern making is not so easy here. Some patterns are not available and some are, but still let's see. So what generally happens is, if we take the divisor as 100, generally you'll have last, as discussed, last two digits as the remainder because of these two zeros. So it would be convenient if we have separated in four different criterias, and those criterias would be, if the base ends in 0, base ends in 0. Second criteria would be base ends in 5. Third would be odd numbers, and fourth would be even numbers. So let us see. So what will happen in the first two cases when base is 0? Let's say I have 20 ka square divided by 100. What will be my remainder?
0.
And 20 cube?
0.
Perfect. Because you will always have, whenever any number, like you have x and then 0 and raised to y. If the resulting last two digits are more than 0 and all, you will always have remainder 0 in this part. What will be the criteria of this? How will this end, guys? Any idea?
540.
Sorry?
5.
Okay, only 5.
0.
0, how 0? If we multiply 5 by 5 by 5, will I
525.
arrive at a condition where my unit digit will be 0?
525.
Yes, 525. I'm asking last two digits, not last digit.
25.
So that is just one scenario, or will I get some more scenarios also? Think guys, think. Will I get some more scenarios also? Try to work it out on paper. You will get a pattern. Try recognizing it.
Getting 25.
That's it. Only 25?
Yes.
Okay. Well, what if I have the tens digit odd or even? Does it change? Like take this and take this. Now start doing the powers 1, 2, 3, 4 and observe the last two digits. You can use your calculators and do this as well. So what do you get the last two digits? You will see a pattern.
For 50 it is 25 and 75.
Yes, exactly. You will
And
have
for
two patterns. You will
25
have
it is
20. Yes, perfectly correct. You will have two patterns, that is 25 and 75. And these are the only two patterns that you will get. Nothing different, nothing extra. So this part is clear, guys? Everybody?
Yes.
Okay. This is a special scenario, these both of them, and these are generally tougher ones. like we had seen in the single digit, what was the at maximum cyclicity of all numbers? Maximum cyclicity?
4.
4.
Yes,
4.
the maximum cyclicity we saw here was 4, and some numbers even had shorter cyclicity. Like
1.
we had
4,
5,
9
we
and
had 1,
9.
right?
6.
Yes, perfect. Same is the case here. You will, in both these cases, the maximum cyclicity would be 20. In various different cases, you will even get less than this. We won't go into this sums right now, but just for knowledge, you can have cyclicity at max as 20 as well in some stages. In some stages, it is less than that. So let us take a common example, and that would be what would guys, one more thing before this doing this. Anybody familiar with this part?
Yes.
Yes.
Okay, so let me rephrase up my question. Anybody who is not familiar with this part? Anybody who is not familiar with this part?
Oh, Kesri, I forgot.
Okay, fine. You have forgot the formula, but you do know what a binomial theorem is, right? You know the basic set list.
Can't remember, it's been so long.
Okay, all right. Well, binomial theorem is a way wherein you can explain a plus b raised to n in terms of n and so on. Like this, here we will have nc0 a raised to n plus nc1 a raised to n minus 1b and so on till we have ncn b raised to n. And what is nc0?
1.
How many ways can we select 0 items out of n items?
1 way.
Yeah. Now everybody clear with binomial theorem?
Yes.
Okay. So if I ask you guys, let's say in all these terms, how many terms are present which are not divisible by b? Not divisible by b.
N minus 1.
Sorry? Sorry, can you repeat? I
1,
did
1,
not hear
1,
you.
1. Only one term.
Yeah, which term?
First term.
Okay. And how many terms will not be divisible by a?
N minus 1.
N minus 1. No. I asked how many terms will
So,
not be
not
divisible
be
by a?
1.
And that would be?
Last term.
Perfect. Everybody understood this part?
Yes.
Yes.
Okay. Perfect then. Uh, let's move forward because this will help you. Like, let's say I have asked you 102 cube remainder when divided by 2. Instead of applying the remainder theorem or something similar, what you can do is you can split it out and you can clearly see all these terms are divisible by 2 because they have at least one power of 2. Only thing that does not have anything related to 2 directly, it might have 2 indirectly, will be this term. So you don't need to divide this, you just need to take this. That would be nc0 a raised to n divided by 2 and put the values of n and a. Got this part clear, guys? Anybody, any doubts?
Can you repeat it, Kesari?
Yeah, sure. Let's say I'm given a question 102 raised to 3 divided by 2 and I have to find the remainder. Now you can do this using standard approaches, that would be the single pattern making. But what if now I do is make a slight change and make this question difficult as to 112 raised to cube. Now when you split this, you will get nc0 and your a will be 100 here, your b will be 12 here. I'm taking this way. So your first term would be and consequently your all the later terms would contain at least one part of 12, right?
Yes.
Yes.
Yeah. So since 12 is divisible by 2, all these numbers would be subsequently divisible by 2.
Yes, yes.
Or let me make the question a little more tougher. Let me make this 3, not 2. 2, you can easily determine whether this number would be even or odd. But when given with 3, now it will become a bit difficult. Let's say suppose you do not know the role of how the divisibility of 3 works. For a second, let's forget this part. Now, 12 is always divisible by 3, right? So any
Yes.
number, if multiplied by 12, is indirectly getting multiplied by 3. Hence, whenever we divide that number by 3, we'll get a remainder 0. So after expanding, all three these numbers will return me a remainder of 0, except this one, right? So basically, your this sum is being reduced to this sum, wherein you have to just solve this. Now is this part clear, guys? How
Yes.
binomial
Yes.
theorem will reduce your time and efforts a lot.
Now let's consider the n value some like 25 or 40, a big number.
Okay.
Okay, in that case I can use the reminder theorem. Okay.
Yes, you have the remainder theorem now. See, remainder theorem using here directly would have been a little tougher. Now it has become a quite easier. Got my point, everybody? Okay. Now let's move forward to one of the theorems, and we have 2-3 theorems that we'll discuss, which are more like different multiple upgradations and versions of the remainder theorem, more like the special cases. So we have Fermat's theorem. And how we'll do that? Let's say P is a prime number. These are the given criteria where we can use Fermat's theorem. So if P is prime and HCF of A and P, A being any number and P being a prime number, will be 1, right? Provided that A is not a multiple of P. Then A raised to P minus 1 minus 1 will always be divisible by P, and the remainder would be 0. Always. This works always, guys. Whenever you have A raised to P minus 1 minus 1 divided by P, the remainder will always be 0. This is a special case and will help you a lot. Let's take example. Let's take any prime number, initial prime number 5, and let's take another A is equal to 3. So what do you have? 3 raised to 4 minus 1. What is 3 raised to 4 minus 1, guys?
80.
80.
Perfect. 80. When 80 is divided by 5, what is your remainder?
0.
See, the theorem works. Now let me ask you this question. Now answer. It is little tough, little on the trickier side, but let's see. 2 minutes at max, guys, and DM me your answers. No, Asvik. Acha, you have changed your answer. So are you confident about the first answer or the second answer?
Second.
Mm, Unfortunately, no. Both of them are wrong. It's little on the trickier side, but I would consider it more of a moderate problem, not a hard. Hint is you have to use the formats theorem. Yes, guys, anybody up with the answer? No, Pradeep. 30 seconds more, guys. Nobody's getting the answer. Let's solve it then. Okay, guys, just uh, looking at the previous one, if we take a is equal to 5, can we say 5 raised to 58 minus 1 will be divisible by 59? Is it possible, guys? Can we say this?
Yes.
So if I say so, there will be a quotient k, right? Remainder is completely 0. There will be a quotient something k.
Yes.
Okay, then moving forward, we can say 5 raised to 58 is equal to 59k plus 1, right? I've done just cross multiplication. Now let's use this and break this down. 5 raised to 58 square into how much will be left, guys?
5.
1 1 5.
No,
5 power
5 or 1 will be left.
58 into 2 is
118. Sorry, 106.
5 cube.
5 cube. Yes, 5 cube. Now how much will this give me as the remainder?
1.
0.
1. 5 is to
59k
58 is
plus 1.
59k plus 1.
No, I didn't understand how we got that 59k plus 1. I mean, 58 power 58 minus 1 is how it is divisible by 59.
I use the format theorem. I use a is
58
equal to
minus
5.
1.
P
Yeah,
is
but
59.
yeah, that I mean, so the doubt I had when I was solving is how can I mean, in exam or maybe now also, how can I conclude that 59 is a prime number?
Oh, okay. Uh, Two methods. I'll tell you two tricks how you can determine if it's a prime number or not. There's a longer method and there's a shorter method. First, let's discuss the shortcut method. All prime numbers can be expressed in the form of this. Almost all. Like if there's a prime number p, it's almost necessary that it will be in this form, but the vice versa is not always true. All numbers in this form are not necessarily prime numbers, but all prime numbers will be in this form.
Okay.
This is the first, and the second would be try if you have to check where n is a prime number or not. Take the square root of n, approximate square root. Like here, it is 59. The number below this having a square root is 49. Number above is 64. So this will be roughly 7 point something, 7.5, we can say 7.5, 7.7. So what you do is try dividing it by all the numbers, dividing it by all the numbers below that number. So here we get is roughly 7.7. Try dividing it from 1 till 7. If it is divisible by any one, this is not a prime number. If it is divisible by 1, it is composite. These are your two tricks on how to determine whether any number is prime or not. Got this
Now,
part clear?
yes, now divisible means now 7.7 should be divisible by.
No. N should be divisible.
Okay.
N should be divisible by all these numbers. If it is not divisible, it's a prime. If at all it is divisible by any of these numbers, it is composite.
It shouldn't be divisible from numbers from 1 to 7. Then it's a prime
Yes,
number.
yes, it is a prime number. It should not be divisible. Write this example down. Yeah, guys, I would urge everyone to note down these two methods. This would be quite useful. I mean, there was one concept wherein in the prime numbers in the next, I would say I would have discussed this like after half an hour or so, this concept would have arrived, but since it was required now, I've discussed it right now. Everybody clear how to find out if they are prime numbers or not? Okay. Now moving forward, 5 raised to 58 is equal to 59k plus 1. This we have concluded from our Fermat's theorem, and using this 5 raised to 58 ka square will leave remainder 1. This part is also clear with everyone?
Yes.
Okay. Now we have is this part is cleared. Now let's move to this. 5 cube is 125. Now divide 125 by 59. That's the normal pen and paper method. What will you get as the remainder?
9.
Calculate again.
7.
7. 59 2 is 118. 125 minus 118 would be 7. Your remainder is 7. So the final answer would be 7. Guys, if you are confused with this method, I will just tell you a shortcut. Let's say x into y into z into a into b. This is not plus, this is multiplication, my bad. If it is divided by p and I need to find the remainders, first I will try dividing each one of them by p. Let's say this gives me a remainder of 2, this gives me a remainder of 3, this gives me remainder of 1, this gives me remainder of 4, this gives me remainder of any number, let's say 7. The final remainder would be 2 into 3 into 1 into 4 into 7 divided by p. If this number is less than p, this is the remainder. If this number is greater than p, then again divided by p and find the answer. This is what we have done it here. This is, you could say, your shortcut to remainder theorem, shorter version. You could say this is a combination of binomial theorem and remainder theorem actually. Is this part clear, everyone? Please note it down. It's very important. You can mention it as a shortcut remainder theorem. Is this part clear with everyone? Anybody, any doubt? Guys, please type in the chat box if you have any doubt. If you don't have a chat box, if you don't have any doubt, please type in the chat box as well. If it is clear or
Yes,
not.
Ray, I had some connection issue. Please, can you repeat?
Repeat from where exactly?
What are X, Y, Z, and A and
Okay,
B?
okay, sure. Let's say x, y, z, a and b are some numbers and you have to divide them by p and you have to find the remainders. Now
Yeah.
instead of multiplying all the numbers first and then dividing it by p and finding the remainders, what you do is you initially divide x, y, z, a and b by p. Let's say you get the remainders as when dividing x by p you get 2, when dividing y by p you get 3, when dividing z you get 1, when a you get 4, when b you get 7. These are your individual remainders. Now what you can do is in the next stage you can directly multiply all those remainders, and if it is less than p, this will be your answer. If it is greater than p, again divided by p. Basically this is what we did here, and
Yeah,
that would
got
be
it.
your shortcut remainder theorem. Guys, is it clear? Please type in the chat box so that I can understand it is clear with everyone. Others? I've received just 4 responses, 2 still left. Anshula and Ashwik, is it clear? I haven't received your responses.
Yes, yes, yes.
Okay.
Yes, Kirsten.
Okay, great. Let's move forward then. Now we will have a specific pattern of questions, and that would be factorial related. And we have a special theorem for that. That is Wilson's theorem. So, what is Wilson's theorem? Here again we have something prime. If P is prime number, then P minus 1 factorial plus 1 when divided by P will always give the remainder as 0. Let's first write it down, then we'll take an example. Let's take a larger number first. Let's take P is equal to 7. Now what will you get, guys?
6 factorial plus 1 by
Yes.
7.
Yeah. Now what is 6 factorial?
1.
720.
20.
Yes, 720. So 720 plus 1 would be 721. Now try dividing 721 by 7 and see what is left.
Yep, remainder 0.
Yep. So this proves it then. This is your Wilson's theorem, and it will be required when you have something of this format. Let's try this out then yet again. What is the remainder when 28 factorial is divided by 29? Find the remainder when 28 factorial is divided by 29. I want the remainder. No, Prerit, that's not the answer. Yes, now it's correct. Others, one more minute. No, Manideep, that's not the correct answer. 30 more seconds, guys. Alright, guys, it's taking way too longer. Let's apply this theorem. So let's take p is equal to 29. So 28 factorial plus 1 by 29. How much will be the remainder?
0.
0. So if I remove this 1 from here, should I subtract a 1 from here as well?
Yes.
So will the remainder be minus 1? Yes or no, guys?
Yes.
Yes, it will be minus 1. Then whenever faced with such a case, what you do is you add this number to this. Minus 1 plus 29 and your remainder would be 28. Now I will explain how this thing works. When dividing in such a number, generally what happens is this remainder theorems, they return f of a. F of a being minus 1 means if I'm dividing 4 by 5, what will this return me as the remainder is minus 1. So on a number line from 0 to 5, minus 1 means it is 1 less than 5. That means taking from this side, how much will it be?
4.
4. And how do we obtain 4? When we add this number to this. Now got this part clear, guys? How did we arrive here? Anybody? Anybody, any doubt, guys?
Kisri, I have
Yeah, go ahead.
simply, can I write down on the screen if you don't mind?
Yeah, go ahead.
You simply add 1 here, minus
Yes.
here,
Yeah.
and this is the complete line like this.
Yeah, you can say that.
And this much part we get 0
Yes.
remainder,
Yes.
and what we get minus 1 by 29, that part you are you directly using this way.
Yes.
I'm not getting this one.
Okay. Okay, I will explain it once again. Don't worry. Anybody who has a similar doubt? Okay, let me explain it again. Now, how do I remove this part? Okay, great. Thank you. So What we saw was 28 factorial. This will give me a remainder of 0, right? Now if it gives me a remainder of 0, that means it will give me a quotient of k, a complete quotient. Let's assume it is k. So
Yes.
can we say 28 factorial plus 1 is equal to 29k?
Yes.
So can we say 28 factorial is equal to 29k minus 1?
Okay.
Yes, K.
Now substituting this in the numerator of the question, this question becomes 29 into k minus 1 divided by 29. How much will be the remainder? Now
-1.
is it clear, Anshula?
Yes.
And when you have a negative remainder, I guess I've already said what is to be done next. Add that number back, you will get a positive remainder. Why we are getting a negative remainder? Because we are calculating it from the right side, but in number line we move from the left side, not the right side. That's it. So this part is clear, guys. Everybody, any doubts? Please type in the chat box if it is clear. Okay, then let's move forward with one more method, and that would be special cases wherein the number is mentioned as in this form. Let's say I have to calculate and this has been repeated till 300 digits. And I have to find the remainder when this is divided by 991. Sorry, 999. Now how will I solve it? Quite easy, nothing to worry about it. Let's see. What is done here being? This is 123 into, first of all, how many times 123 will get repeated, guys?
3.
Multiple of 300 times.
100 times.
300.
300 digits, and 3 digits occupy 123. So we will have 123 how many times?
100.
Perfect. So can we have this in terms of binomial theorem? Can we expand it in terms of binomial theorem? Like, not exactly binomial theorem, but on similar lines. Like, this will be 123 into 100, sorry, not 100, 1000 raised to 99. Can I write this as this? Yes or no, guys?
How did you get 1000 is to the power? Because it is a entirely single digit, right? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3.
Yes.
I'm still
I'm
confused.
asking, I'm not telling, I'm asking, can I write 1000 or will there be some another number? I'm asking you guys, I'm not telling this is the right answer. I'm asking whether is it right or not. If it is not right, then what should come here? I just want to represent only these three numbers, these three digits, and after this, there are all zeros. Can I write it in this form? Yes or no?
Not getting.
Yes.
Okay. I'll show you the trick. What I'm trying to get here is, what did we do in our remainder theorem? Let's go back to our remainder theorem. What did we have here? F of x, when divided by x minus a, the remainder will be f of a. Is this part clear, guys? What I'm trying to do here is, I'm trying to put my x is equal to 1000 and a is equal to 1. So can I say the denominator is this? And I will put,
Oh, now I got it.
yeah, and I will put this in this terms, like how many zeros will this contain?
6.
Now,
It goes on 9.
yes, perfectly. Now 12.
Yes.
Okay. How many zeros are there in front of first 123?
297.
297. How can we get 297 then?
Minus,
300 minus
because 300 digits are there.
Can we get using this way?
Yes. 993.
So was I correct here? I haven't mentioned the complete number. I'm asking just this part.
Yes. 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 Correct.
Okay. For next these 3 digits, can I say 123 into
Yes. Correct. Makes sense.
finally I will arrive at a point where it will be
Yes. Basically, we are using the numbers concept where if x, y, z is a number, then 10x plus 10y plus
yes, yes,
z is
yes,
the actual
yes,
number.
yes, exactly.
Oh,
Here we have taken the base as 1000, that's it, instead of 10. Because we are considering 3 digits at a time and not just a single digit. If we had a single digit, we would have considered the base as 10. Everybody clear with this concept?
Yes.
Okay. Now use your remainder theorem and tell me what is the answer. I've simplified it to you in remainder theorem terms. Now tell me what will be the answer. Yeah, guys, come on. This is not that tough.
Twenty-three power 100.
No. Guys, this is easy. I don't know why are you guys confusing it. See, what will be our x here if we compare this with this?
1000.
X is 1000. So can I say the above polynomial is 123 into x power 99 plus 123 into x power 198, so until 123 into x raised to 0 divided by x minus 1, right?
Yes.
Now use the remainder theorem. What is your a here?
1.
1. Now put the value, now find the value of f of a, that will be a remainder. If the number is, yeah.
Is it 123 into 100?
100.
Yes, it is 123 into 100 because 123 will come 100 times.
100 times.
Yes.
So 123, 100. But our divisor is smaller than this
999.
number. So we will have to divide it again. Remember what I had mentioned here before? Where did it go? Yeah. When you obtain a number which is still greater than p, you will have to divide it again. The same thing has to be done here. Now divide it. Whatever you get will be your answer. This you can do it with your calculators as well. Now what did you get the answer, guys?
12. 312.
Yes, 312 it is. Everybody getting this part? Guys? Everybody getting this part?
Yes, we
Yes,
get it.
yes.
Okay. Anybody who did not get this part? Please respond. I will ask. I will explain it again. Okay. Seems everybody has understood this part. Great there. Now coming to the
Answer
Ashrit.
is 22.
312. 312.
312.
Yeah.
Okay.
Moving to the final part of numbers 2, and here we will have rules when you have to apply when dealing with these patterns. So first, let's it be if it is always odd, n is odd, then this number will always be divisible by a minus b. And when n is even, it will always be divisible by a plus b. It applies to both the cases, this as well as this. When n is even, it will be divisible by a plus b. I mean, that means the remainder will be 0. Please note it down, guys. Note it down carefully. I will wait 10 seconds so that you won't be in a rush.
Casey, both the columns, whether plus or minus, will be divided by these.
Sorry, I did not get you. Could not hear you properly.
Means if n is odd, you
Yes.
say it will be divisible by a minus b.
Yes. Completely divisible. And when n is even, it will be completely divisible by a plus b.
Left side or right side?
Both. Both of them. Is this part clear, guys?
Yes.
Oh no, sorry, 1 second. Acha, you were asking of this. No, this is only for this. Only a raised to n minus b raised to n. Yeah. This is only raised to this. This I have to discuss.
Okay.
Yeah. Is this part clear, guys? Now, for this case, if n is odd, it will be divisible by a plus b. And if n is even, it will be divisible by a minus b. Is this part clear, guys? Everybody?
Yes.
Yeah. Now
Yes.
write down one special case in this, both of them. Put a star mark here and here as well. And that is, these conditions will only be satisfied when, in this case, when n is odd. I'm writing it here. This will always be, 1 second. This was, yeah. Did I mistake in writing? My bad, my bad. I wrote it opposite. My bad, guys. This will be also be a minus b, and this will be a plus b. The thing here will be, this will be applicable when a minus b is a factor of 2 times b raised to n. And in this case, a plus b is a factor of 2 times b raised to n.
Kesari, it is for a power n minus b power n, it's a minus b only, right?
Yes,
So basically it's same for everything.
yes.
Okay.
Is this what clear, guys? This will help you in solving a lot of questions. Like, let's for example, take a small question. 11 raised to 103 plus 14 raised to 103, and I'm giving the options as well. It will be a multiple of which numbers? Answers in the chat box. It will be divisible by which numbers? Mind you, this is a tricky question, not an easy question. This will show you the limitations of this formula, because this formula has some limitations. Every formula has, and I've specifically chosen this example.
Yeah, the number will go to negative, right?
Yes, it will. There's one exception which I need to discuss. That's why I've given you this formula. Prerit is telling me 7 and 35. Okay. All right, guys, I will disclose the answer. One thing. 1 cube plus 4 cube. Will it be divisible by 5?
Yes. 65.
Everybody? It will be divisible by 5. Now write down an exception here. That is, when n is odd, this will be divisible by a plus b under all cases, but when is odd, it will be divisible by a minus b in only under this scenario. I'll tell you two methods on how to solve such problems. First, you write it down. I've given this formulas just for your reference. I generally do not use these formulas. I use some methods and not the formulas. Written, everybody? Everybody has written?
Yes, from
Yes,
my
yes.
side.
Okay.
Yes.
Okay then. See, whatever you are getting this all. These are the results being acquired from the binomial theorem and various theorems we have discussed above. Trust me, these formulas can get confusing, it can get irritative, or sometimes it becomes difficult to remember. So whatever basics we have learned of all the pattern making and every formula, try remembering them. If it doesn't help, what I did is, see, this was the question given. Without knowing a formula, can I take a similar example and solve it? And then try to use the same thing here. Do I need a formula for such questions? No, I don't. Now, what will be the answer in this question?
25.
Yes, perfectly. I just have to use the concept I used here to solve it here. And that's why I do not remember this formulas generally. Having a formula is good sometimes if you get confused or so, but coming up with such methods would be better.
Kesari, one doubt I have here. So,
Yeah.
in the second case where a minus b is a factor of 2 into b power n,
Yes.
so now let's consider the example we use b power 14 power 103.
Hmm.
So how do we find out the fact if it is a minus b is a factor or not?
That's the thing. That's the limitation of a formula. Like I had mentioned, every formula has a limitation. This formula can, this formula, what it will do is again, it will modify a question into something different.
Yeah,
Yeah,
a lot
that's
of
the thing.
confusion.
That's why I said I do not use these formulas generally.
Okay.
I
And
gave you
even,
these formulas for reference.
and even a minus b is getting minus. I mean minus 3. So that is
I
again
get it.
another confusion.
You can take B minus A in that case.
Okay.
That's not the thing.
Okay.
See, you can take this as A and this as B, right? Or you can take this as A and this as B. Will it matter here? No, it won't. I generally prefer such things because see, it's a quantitative aptitude, not the mathematics test like I had mentioned before. And these formulas are for your worst case, like let's say you are going for an exam and you are not able to come up with such things. Just having these formulas can sometimes save you, because even a one question can make significant difference in your percentiles. It matters a lot.
Okay.
Whenever you solve questions, try using such methods first, and the methods that we have discussed. This formula should be your last ditch scenario, like you cannot think of anything else. Now let us try the formulas. Is it clear, guys? Everybody? Okay. So with this, we have come to the end of numbers 2, and we'll move forward to the next part. That would be numbers 3. Now, just before numbers 3, guys, we won't be able to finish numbers 3 completely. So what I'll do is just we'll discuss the basics first. In numbers 3, what we have is number systems. Now, what are number systems? The base. For example, we use the numerals 0 to 9 to write down all the numbers. We had discussed this in the first chapter of numbers. And how does a number work? 1 till 10, then again it starts with 11. We have a 10 in every number till 20, then 21 to 30. What is the base of this number system?
10.
10.
10. Perfectly. Anybody who does not know how this we came through 10 is? Anybody having any doubt why this 10? If so, I'll explain it. 24, how does it derive its value? This is 2 into 10 plus 4. This is the base, and that's why this 10 is the base of our number system that we use. Anybody who is just aware of how the computers work, what base does the computer use?
Binary.
Binary.
Yes, and the number is?
1 0.
1 and 0.
So the base is?
2.
2.
Yes, perfectly. The base is 2. So the number of digits in your number system would be equal to the base. How many digits we use in the 10 base system? 0 to 9, 10 digits. How many use in the 2 base system? 0 and 1. So, and this is known as the base 10. We have now two things: conversion from one base to another base, and then back to this base. So let us say we have a number 10. Now if we have to convert 10 to the base of something in the base of 2, how will we do it?
10 divided by 2, then take the remainder.
Yes, perfect.
Yep.
We'll take 10 divided by 2. We have 5. Remainder was 0. Again 2. Remainder was 1. What will get here?
2.
Yes, perfect. Our remainder was 0, and finally we get is 1, which will be written here. Now in which order will we write it?
नीचे से ऊपर.
Exactly. So this will be
1 0 1 0.
And how do we go from this to this back here?
We multiply
Yes, how?
with the we start from the very right one.
Perfect. So what we'll do is we'll index our numbers. That would be 0, 1, 2, 3. So this will be 2 into this, and the power of 2 will be this, plus 2 square into 0, plus 2 raised to this into 1, plus 2 raised to 0 into 0. What do we get here? 8, and here 2. This is 10. Works perfectly, guys. So if I ask you guys, what is 101 base 2 plus 011 base 2, what you should ideally do is, how will you proceed, guys? Will you solve this two directly, or you convert this to 10 base 10, you convert this to base 10, and well, we are well aware of how two numbers in base 10 are clearly to be added, and then convert them back to base 2.
No, we can directly
We can
add.
directly do an AND operation.
Okay, what if I take it to base 8?
Then also we can do.
AND operation.
No, but we have to take care of the number of digits for the carryover.
Yeah, but which do you think will take more time?
This one would take more time when the base is 8.
Yeah. So if given any number like 264 to the base 8 plus Aswik is already feeling sleepy.
Oh shit.
Happens. And 372 to the base 8. Mind you, I cannot have digits greater than 7 in base 8. If this is the case, then what can I do is, I will do is, there are two methods. Directly add them, but you'll have to take care of the powers. Or you can do is, convert this to base 10, convert this to base 10, add these numbers normally as we add, because we are very good in adding bases of number 10, and then convert this addition into base 8 again. Choice is yours. You can do both of them. So you guys know how you will convert this from base 8 to base 10? Anybody who can tell me how I will convert this from base 8 to base 10?
We'll convert it to binary first.
No, base 8 is
Then
8, 8 power 0 into 4, then 8 power 2 into 6, then 8
Yes,
power 3 into 2.
perfectly.
Then
You
that
can
brings,
directly do it, guys. See, what does the number system mean? Like, let's say here it is 572 to the base x. What you do is write down the indices 0, 1, 2. Now, how will you represent this number in terms of base 10? Would be 5x square plus 7 into x raised to 1 plus 2 into x raised to 0. This is what is your value in terms of base 10. That would be 5x square plus 7x plus 2. And this can be any number, even 10. When it's 10, it will come out to be 572. Back to the same number because it was originally base 10. And when we have to convert this from base 10 to base 8, divide it by 8 using this method. And write down the remainders. Is this part clear, guys?
yes. So if it
Every
goes to hexadecimal in that case, then we have
same
to,
thing. We
yeah,
have
we
base
have to,
60,
okay. Then we have to use
hexadecimal.
the ABCD convection.
Yes, ABCD. In base 16, we actually see we have till 0 to 9 in terms of base 10. What if the base is 11? Will you write the digits as 5, 70, 10? Because then I won't be able to understand whether it is 1 and 0 or whether it is 10, right? So we use the convention 10, 11, 12, 13, 14, 15 as A, B, C, D, E, and F. The hexadecimal codes are used. So this into base 11 will be written as like this, and you will have to understand it. Is this part clear, guys? How to go from base 10 to base x and how to return back from base x to base 10? Everybody clear with this part? This is very important, guys, trust me, in numbers 3.
Yes.
Everybody?
yes,
Yes.
Okay,
Yes.
great.
So
Now
Kesari, what is the highest degree we get till hexadecimal, or it goes on? I mean, in cat.
you will have till 16, base 16 only.
Okay.
See, the thing is, even a computer operates at max till base 16. What happens is, if we start having more than base 16, what will happen is it will increase the complications. Let's say, for example, you purchase one car. Now have your parking garage, or in your society, you might have your parking space. You can park it. Now you purchase two cars. Well, having two cars is great, but now you'll have to manage your parking space. What if the number becomes 3 or 4? Always having more numbers is great, but then your managing part will become difficult, right? The same works with a computer as well. So generally we don't go beyond the base 16 because that is like kind of a safe number where the calculations and the speed and managing everything goes well, and hence you won't find generally problems which are greater than base 16. Okay, now moving forward, I'll give you one observation one, and that is 2 raised to square, that is 4. 2 raised to 1 is 2. 2 raised to 0 is 1. You will note that this is always 1 greater than the sum of all of these. 2 raised to n is always 1 greater than summation of all the numbers from 0 to n minus 1. Always 1 greater. You can derive this or you can learn it. There are two methods. Is this part clear, guys?
Yes.
Anybody any doubt? Okay, great. So this was the basics of numbers 3. Numbers 3 will take roughly half an hour more, not much. But if we extend you half an hour more, this will be more than enough. We have already had 2 hours today. So I guess this will be it for now. And we'll see the number 3 when we'll be meeting the next time. Okay, guys? And
Yes, yes.
also you have your section test coming up, guys, so please revise carefully and diligently, and if at all you have any doubts in anything, post it in the group and be in touch with your mentors as well. Okay, guys, then I hope everything today we have discussed is clear. Anybody any doubt, ask me right now before taking a leave. Any doubts, anybody?
Okay, sir.
Okay, great then. Thank you, guys. And yeah,
Thank you.
have guys, one more thing. I would just suggest you one thing. There's a feedback form that is present in your Concur as well. I would remind everybody to please fill up that form as well. Just a reminder for you guys. Okay. Yeah, guys. Thank you.